Hey guys, it's your boy, back at it again with day 2 of Systems Analysis and Design Research for the exams. So today we're going to be looking at Rapid Applications Development and Joint Applications Development, or as they're better known, the boys, RAD and JAD. So yesterday we looked at the software development lifecycle, or the systems development lifecycle, in which it's a very document heavy approach. But what we're looking at today with RAD and JAD is an agile approach, which is kind of like the antithesis, very document light, very quick to do, all very last minute, exciting stuff by comparison. So one way to describe the agile approach compared to the SDLC is it's very user-centric. As we know, the SDLC does start off being user-centric when you're trying to establish an end goal. However, along the way, you kind of lose the user input as much. There are exceptions to this, don't get me wrong, but Agile is all about the end user. It's all about making code samples for the end user to test, or for testers to test, I suppose, as well, so that you can improve upon or correct any issues along the way. It's all about making little baby steps as opposed to making big leaps over the course of a long time. Clothes change. So these baby steps are also known as sprints, and they tend to take about 3 or 4 weeks per sprint. You do this throughout the whole process and you develop a good code artifact to be used in the end. So it's time to talk specifics. We'll start off with our boy RAD, Rapid Applications Development. It's as the name would suggest. So you take the elements of the SDLC and you kind of iterate through them over and over again, as opposed to doing it definitively each time. To be honest, a diagram's going to be best, so I'll just put it there. So as we can see, it's pretty much the SDLC at each stage of the process, and we iterate through it. And we just adjust each little element of it as we go along. However, one small problem that we see here is we've got JAD, which we haven't quite explained yet, so we'll go on to that now. So joint application development is a very structured way of deciding where the next step in the process is going to be. So you'll have a nice agenda already laid out of what you're going to be talking about the different prototypes, and then you have all different sorts of people coming in to decide and test what's going to happen next. So you've got end users, you've got developers, you've obviously got people who are organising it and orchestrating it, you've got experts in the area, so you get a good opinion from more than one group of people on the project. So as you can probably tell at this point, the positives of RAD and JAD are kind of linked to each other. So rapid application development is quick. It's very, very quick. You're going to be able to make a project a lot faster, well, most of the time at least, than the SDLC. Furthermore, it's going to be a very high quality end product, particularly for the client, because they're going to have had so much input into it. However, there are also negatives. So because of the nature of rapid application development, there may be some features that have to be missed out because of the time constraints that you're putting on your programmers. Bit of a problem. Also, when it comes to JAD, Joint Applications Development, you've got the issue of it being quite costly to get all the people in and orchestrate a meaningful conversation. Furthermore, it's not always meaningful. It's down to the skill of the people who are organising it in order to make that next step. So we've talked about RAD, JAD and Agile, but now it's time to talk about some of the applications that people who use this kind of process may use. First of all, case tools. So case tools, or computer-aided software engineering tools, are there to basically help the people who are using the Agile approach to make a product for the users to test. Once again, the best thing to do is to get another diagram up. So as you can see from the diagram, it's very helpful that the case tools are able to generate code and tests for us. It basically means that not only the programmers are going to get benefit out of it, but the end user can actually see what's going on. It also helps with software quality. So the fact that the end user can see it means that everyone's going to be speaking the same language when improvements are suggested. Everyone can scrutinise it. Very helpful indeed. So I used a word there that's kind of loaded, and that's software quality. It's something we all think that we understand, but put more specifically, it's whether or not a piece of software is fit for purpose, and a good word to describe this would be robust. Achieving good software quality is quite a laborious process, but there are quite good ways to do it. Mainly it's just to have good standards in place and to have checkpoints to make sure that everything's being met along the way. My bed frame has been sorted, just for you, Tom. Thanks for watching once again. Always a pleasure, never a chore. I'm hoping that this is helping somewhat. I feel like it's helping me probably more than it's going to be helping you. It's just me trying to solidify my understanding of what we're doing, even if it is basically just reading through PowerPoints and then talking about what I've read. Thank you very much for your time, and see you maybe tomorrow.